So I had a student ask me about this question in math, and this is a exponential decay question. This isn't randomly generated, so I kind of don't want to do this question, because once I do it, you'll have the answer. So I'm going to do a similar question. So I went out, so in recording this in summer 2019, and what's happening is there's a lot of measles being reported. People aren't getting vaccinated and having their children vaccinated, and this is some data from the CDC. So I was going to concentrate on the growth, because this looks, I mean, there's some very fluctuation going on here, but then when I look in the month of March, I see kind of an exponential growth. I mean, there's a dip here, but kind of looks exponential growth. So that's what I'm gonna focus on, and I'm gonna approximate some numbers here. I'm gonna call the start of March day 0. 1 week later is day 7. 1 week later is day 14. Another one in day 21, etc. And then my calculator, I'm going to get the data into the stat list. I don't know if you've done this, if you've ever done this before, so I'll walk you right through it. The way you get your data in the calculator is press the stat button, and type a 1 or press enter, because the 1's highlighted. And then you see your stat list, and I have some data in there. So to clear that out, and I press the up arrows so the list number is highlighted. I'm going to press clear, and then press enter. That clears out the list. Now, if you accidentally do this, I'm going to show you this, because I know this is going to happen. If I'm up on the list name and I press delete, the list goes away. And how do you get it back? Well, do stat number 5, setup editor, and then press enter. And that resets it for you. There's some other features that does, but we won't go into that for this video. So stat edit. So now I'm going to take the time, and I'm going to stop the recording, because I'm going to do 0. There were about 30, I don't know, 35 or so, maybe 30, 37 or so cases, and that's what I'm going to type into my stat list. I'm going to put the days into L1, and I'm going to put the number of cases into L2. So I've got those numbers into my two lists, and as I said, I did some approximations. So let's see if this does look like it's an exponential situation. It won't look quite as nice as that one in mild math, but that's because it's a canned question. They made it look that way. So let's see. So get a scatter plot on your calculator. We're going to do second y equals here. Let me clear this out. I'm going to do second y equals. And then I'm going to go to plot 1. I'm going to make sure it's on. I'm going to make sure that the scatter plot is selected. And then it automatically tells me, what do you want your x list to be? What do you want your y list to be? Well, I want time to be on the x-axis and the number of cases to be on my y. And I'm also going to do one other thing before. Whoops, I don't have it on. I'm going to come back up. I'm glad I noticed that. Enter on. There we go. So it's on, it's dark. Scatter plot selected, got my two lists. I'm going to go to y equals. I'm going to make sure I don't have any other equations being graphed. And it looks like this calculator's clean. So you can clear it out. You can turn them on or off, whatever you want to do it. And then if you press zoom and you scroll down to number 9, what that's going to do is that's going to snap the window to fit your data. You don't have to play around with trying to figure out what it is. See where it says zoom stat? So the easy way to do that is just do zoom and then type 9. And there's my scatter plot. And I don't know. Certainly isn't a really strong exponential relationship, but I can kind of see it looks like the curve. Part of the problem is I only got 5 data points. But so now what I'm going to do is do a regression equation. And the way you do a regression equation on these calculators, I'm going to go stat. Let me clear out the key press issues. You can follow along. I'm going to press stat. I'm going to arrow over to calc. And then I'm going to come down to exponential regression. If you ever take a more advanced statistics course, you'll find out that this is not the way you want to do it. You want to try to make them linear, but that's not here. We're trying to get you to see what the exponential. So choice choice 0 does on this calculator, does the exponential regression. What's the X list? What's the Y list? We don't need to store the residuals. We don't have any frequency. We're just going to come down, calculate. And I've got an exponential equation. Now, one thing I noticed and I'm missing, and I really want to see this. I want to see how strong a relationship my line actually has. I noticed there was some flux and when I was looking at the curves. So you only have to do this once in your calculator, because this is the calculator that I turn on the computer every time, and I don't store it. It's never stored, so I got to do this every time. But if you press second, and then 0, which is catalog, we're going to come down to diagnostics on, which means you can scroll down, or I'm just going to do alpha D, and you're going to do it twice for some reason. So alpha D, then I'm going to do again alpha D. That'll jump me down to the D's. And I'm just going to come down to diagnostics on. There we go, on, and press enter. Now when I do my regression, stat, calc, what was it, 0, exponential regression, the list. Now we see this R squared value. R doesn't really matter in this situation. We didn't convert it to a linear relationship, so we want to ignore that. But R squared is important. This is telling me that about 80% of the change in the number of cases can be explained by an increase in the days. So that's a relatively strong relationship. Now, to get this to graph on your calculator, and you don't have to do this to make my open math happy, but it's good for us to see as humans. Go to so we can get that, because I just calculated that regression equation. What you're going to do is go to y equals, then you're going to press vars, and you see where it says choice 5, and then we're going to come over to EQ for equation, and that's your last calculated regression equation, what's going to dump in a y1. Now when I just press graph, I don't have to do zoom 9 because I've already done that. I haven't adjusted that. So I'm just going to press graph. Then you get to see our regression equation plotted on top of our scatter plot, which is pretty good. Now, seeing the equation on there makes those points certainly look a little more exponential to me. Okay, so now what happens if I want to estimate, use this regression equation to estimate when are the number of cases going to be, how 10 days into the month, what were the number of cases? So what you can do is you can press trace, hit trace, then make sure, you see how it says P1? You're on your scatter plot. We want to be on the line. So when I press down, when I go down, press the down arrow, see how now it's the Y1? That's my regression equation. And I can use left, right if I want. I can also, if I want to do 10 days in, I'm just going to type 10 and enter. And so there were so using this model, that says there was about 43 cases. Okay. Now, when were the number of cases equal to 50? Well, then we can do this. We can say y equals, come down to, and we want to know when is y equal to 50. We want to know what x that is. So let's graph that baby. And there's the line y equals 50, and I want to find the x value where that's true. So I'm going to do second calc intersection. And the first curve is your regression equation. The second curve is my horizontal line. And then you don't have to guess it. There's only one intersection. That tells me during day 14, there were 50 cases. Now, the next thing in that math question asks, estimate the half-life? Well, this is in a decay equation. This is a growth equation. So we can't estimate the half-life, but we can estimate the doubling time. So we could do this graphically, maybe, perhaps. I don't know if our data, I don't think our data doubled, right? If I do stat edit, our data never really doubled, did it? Oh, yes, it did. It went from 38 up to 38 up to 88. So that doubled. Maybe we can do this on our graph. So let's graph this baby. Come down to us. Actually, let me get rid of the I don't want to get rid of that one. I want to get rid of the equation. Let's see. Well, let's see when, let's see. How about if we do this? What if we say, when was it 30? We'll have it graph y equals 30. Then we'll have it graph y equals 60, and then we'll compare the x values to see what the difference is from the graph. Let's see how this does. So there's a 30, and there's the 60. So let's find those two intersection points. I think it's going to be easier to do this by hand, but we'll do it this way. So I'm going to do second calc intersection, first curve, yep, and then I'm going to come down to that bottom line. There, that one, and I'll just let it do its magic. So at 1.02, so I'm going to write that down on paper, or maybe I can do it this way here. Just a minute here. Annotate. Let's see. Board's not on. Just in here. Give me a second. Technological issues. Here we go. So at day 1.02, there were 30. Then we're going to do, let me come back here, and then we're going to do second calc, intersect again. First curve is your regression equation. Second curve is not 30. We want to do next one when it was 60. Here we go. Enter, enter. Found that intersection. So at day 18, let's see. So at day 18.76, there were 60. So I'm seeing a difference. If we subtract those, that would be about the half-life. Can I do that in my head? Let's see. So at what, about 17.74 is the days is the half-life. Okay, so that's, I'm sorry, is the doubling time, not the half-life. So that's how you do this question straight with a calculator. Okay, hopefully that'll help and at least get you right way there. The other way to get that, get the half-life or the doubling time, I could say if my equation was, what was my equation? If this is my equation, what is it, 28.8? So I could say when is 28? So I could say when is 2 equal to 1.0399 to the x, and then solve that equation, just rewrite it as a logarithm, right? I could say log 2 over log 1.0399. That should be about the same number. Well, let's see. We've got a minute. If you don't mind me running the video, doing the video. Let's see. Let's quit this. See how close my estimate was. It better be close because I don't want to have to redo this video. Let's see. Log 2 divided by log 1.0399, I said. Yeah, about 17.7 days. Okay, so that's how you do it. Hopefully this helps.